For number 4, we're going to find the producer surplus for the product. This time the supply function is given and as an exponential. And the x or the equilibrium x is 5 units. Okay, for the supply function gonna be like increasing function. So Sx equals 9e to the 0.4x. And then the equilibrium point at xe equals 5. So that means gonna be this one is the equilibrium point, the xe, the PE. So we are looking for the producer surplus, and this point is the PE, which is the same as the S at XE. The producer surplus is going to be the additional area here. Okay. First, we're gonna set up producer surplus. I use as a PS, producer surplus. So PS is from as the greater area, which is the area of the rectangle. Okay, and then subtracted by the area under the curve. So I can put the notation like, the symbol as the rectangle, and then subtracted by the area under the curve of the supply function. So for the rectangular one, that is XE, or the length times the width, or the XE times the price at equilibrium point, and then subtracted by the area under the curve, the supply curve, which is 9 e to the 0.4x with respect to x, and evaluate from the lower limit 0 to the xe. Okay, and this one is the supply function. So replace it. The x, which is the 5. Again, the p we don't know yet, right? Same way as what we did in the last problem. What is the PE, or the price at the equilibrium function? Equilibrium point, sorry. So PE is the same as S at the XE, which is the supply at 5. So we're gonna plug it in, 9 times e to the 0.4 times 5, which is e to the second. So 9 times e to the second. Okay, so we got that. So that means we're gonna multiply 5 and 9 times e to the second first, and then subtract it by the integral from 0 to the xe, which is 5. And then integrand is 9 e to the 0.4x with respect to x. That's the setup. And the next part, what we're gonna do, we just clean up the terms and then find the antiderivative. But this time we're gonna have to leave the first part here for now until we all done the antiderivative part and evaluation at 0 and at 5. So the first part becomes 45 e to the second. Just keep it in the exact form first and then round it at the end at the last calculation. The antiderivative that we're going to use for this is the exponential function. So we're going to use the exponential rule. The integral e to the kx with respect to x equals e to the kx divided by k. What is our k? The k in this part is 0.4. Okay, k is 0.4. So we're going to apply that rule. And also 9 is the constant multiple or the coefficient. Okay, so what we're going to do, the constant multiple or the coefficient doesn't change anything. And then for the exponential rule, going to be e to the 0.4x and divided by that k, which is 0.4. And then put the bar in the back, the integral and dx, they come together, they go away together. We're going to evaluate from x equals 0 to x equals 5. And then we're going to simplify more, 45 e to the second subtracted by, so this is 9 divided by 0.4. If I write in the nicer form. So I should get 22.5 as the coefficient. And then e to the 0.4x evaluate from x equals 0 to x equals 5. What I can do, I just do just this part that I substitute the value in. As you see, the first number is the real number. We don't touch it for now, okay? So the next step, evaluate at the lower limit, upper limit. I'm gonna treat toward 22.5 as the common factor. So I will do not multiply each time. I just multiply after I'm done subtracting the substitution by the upper limit and the lower limit. So this is e to the 0.4 times 5 or the upper limit. And the lower limit is e to the 0.4 multiplied by 0. And this time I will not get lucky if I forget the second part here, because e to the power 0 is 1. It's not 0, so I have to leave it. And this part is e to the power second, right? And now what do I have? I have 45 times e to the second minus 22.5 e to the second. Negative becomes positive, and then plus 1, or actually plus 22.5, because you multiply to both terms. Okay, and it's before I put in the calculator, it's very convenient. I see 45 and 22.5 as one is the half of the other. So that means I can just put in the calculator as 22.5 times e to the second and then add it by 22.5. Another nice thing, I have the common factor 22.5, and then I just pull it out of those two terms, becomes 22.5 times e to the second plus 1 as a nice exact number. And then I just put in the calculator. What do I get as the approximate or in the decimal form? Okay, I have 188.75 as the producer surplus.